Welcome to NightLesson. Relax and learn along the way.
Intro: Humanity's greatest question. Imagine you are looking up into the infinite night sky, a deep, velvety cloth strewn with myriads of sparkling lights. In this vast cosmos, a question echoes, one that has captivated humanity since time immemorial. The great thinker Arthur C. Clarke once put it so aptly: two possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying. Let us pause for a moment and grasp the sheer magnitude of this statement. Consider the numbers with me. It is estimated that there are about 200 billion galaxies, and each one on average is home to 100 billion stars. If you multiply these incomprehensible numbers, you arrive at a sum that far exceeds the number of grains of sand on all the beaches of our Earth. Statistically, it seems almost impossible that our small blue planet is the only place where life, let alone intelligent life, has blossomed. And yet, when we listen, when we watch, there seems to be no one there. This profound paradox led the physicist Enrico Fermi to ask his famous question during a luncheon in 1950, "Where is everybody?" Since that poignant moment, we, as humanity, have been searching for an answer. We develop theories, peer through ever more powerful telescopes, and send messages into space. Yet every potential explanation we find seems to draw us deeper into a spiral of intellectual tension and existential unease. Is the answer that awaits us perhaps even more fascinating and frightening than we can imagine? Chapter 1: Why Life Should Be Probable. Imagine for a moment the infinite darkness of the cosmos. A velvety curtain embroidered with countless points of light. Each of these points, which we perceive as a star in the night sky, is a distant sun, a colossal sphere of glowing gas radiating light and warmth into its surroundings. Our own sun is just one of these stars, a rather average star in one of the outer arms of our home galaxy, the Milky Way. But the Milky Way itself is only a tiny part of a much larger picture. Astronomers estimate that there are over 200 billion galaxies in the observable universe. 200 billion islands of light, each one home to hundreds of billions of stars. Let this number sink in for a moment. For every blade of grass in a vast meadow, for every grain of sand on an endless beach, there is an entire galaxy out there to discover. In this cosmic ocean of stars, scientists have begun to search for planets orbiting these distant suns. And what they have found exceeds all expectations. It is now believed that planets are not the exception but the rule. It seems that almost every star is accompanied by a family of planets. And among these countless planets, there is a special category that fascinates us the most: the Earth-like planets. Worlds of rock, located in the so-called habitable zone around their star, that perfect distance where it is not too hot and not too cold, so that liquid water could exist on the surface. Estimates vary, but even the most conservative calculations lead to a breathtaking conclusion. In our Milky Way alone, there could be tens of billions of such potentially life-friendly worlds. Multiplied by the number of galaxies, we are talking about trillions of planets that could be similar to Earth. Trillions of stages on which the drama of life could have arisen. Scientists have tried to capture this staggering probability in a thought experiment sometimes called the Drake equation. They posed a series of questions. How many stars are there? How many of them have planets? On how many of these planets do the right conditions for life exist? On how many of those does life actually develop? And on how many of those does intelligent life arise? Each answer, even if we can only estimate it, reduces the total number. Yet even if one makes pessimistic assumptions for each step, a number greater than 1 remains at the end. Then there is the factor of time. The universe is about 13.8 billion years old, a seemingly endless span of time in which stars were born, formed their planets, and passed away again. Billions of years in which the simple building blocks of chemistry, carbon, hydrogen, oxygen, had time to combine into more complex structures. It is a time span so vast that rare, random events leading to the origin of life become almost inevitable. Statistically, based on the sheer numbers and the time available, the universe should be teeming with life. We should not be alone. The great silent night sky should in truth be a choir of countless voices. The expectation of finding signs of life is therefore not mere fantasy, but a logical consequence of what we know about the cosmos. and yet there is a great silence. With all this cosmic expanse, it is only natural that we begin our search where we stand, on our own wonderful Earth and in the deep echoes of its own enigmatic past. Chapter 2: The Futile Search. Imagine you are standing in a wide open field on a clear moonless night. Above you, the sky arches, an infinite sea of sparkling stars. It is a sight that has fascinated people for ages and inspired one of the deepest questions: are we alone? From this deep human need for connection, for an answer from the darkness, one of the greatest scientific endeavors of modern times was born. The search for extraterrestrial intelligence, or SETI. This search is not a loud, excited shouting into space. It is rather a patient, almost meditative listening. For over 60 years, astronomers have been pointing huge radio telescopes, like gigantic sensitive ears, at the cosmos. They listen to the gentle hiss of the universe, the echo of the Big Bang, the pulsing of distant stars. And amidst this cosmic symphony, they search for a single, tiny anomaly, a note not composed by nature, a signal that bears the unmistakable signature of technology, a pattern, a structure, an artificial heartbeat in the void. It is a search driven by a deep hope, the belief that somewhere out there another civilization is also looking to the sky and sending a sign. In all the decades of patient listening, there was one moment that made the researchers' hearts beat faster. It happened on a summer night in 1977. A radio telescope called the Big Ear in Ohio recorded a signal so strong, so clear, and so different from anything ever heard before. It was a narrowband signal, exactly the kind of transmission one would expect from an advanced technology. It lasted only 72 seconds, a fleeting moment in cosmic time. When astronomer Jerry Emin later reviewed the printed data, he was so stunned that he circled the string of characters on the paper and wrote just one word beside it. Wow! The wow signal became a legend. It was the most promising candidate for an extraterrestrial message to date. Immediately, astronomers pointed their telescopes back to the same spot in the sky, full of anticipation, hoping to hear the signal again, to confirm it, perhaps even to decode a message within it. But they heard nothing. The spot from which the signal had come remained silent. They searched for weeks, for months, for years. Other telescopes around the world joined the search, but the signal never repeated. It was like a single clear word whispered from the darkness and then swallowed by the silence forever. The initial euphoria gave way to a deep, nagging disappointment and an even greater mystery. Today, the search is more comprehensive and advanced than ever before. Projects like Breakthrough Listen, equipped with the most sensitive instruments humanity has ever built, are scanning millions of stars across billions of frequencies. Our technological capabilities have grown exponentially. We can now detect signals that are unimaginably faint from the most remote corners of our galaxy. We are not only looking for radio waves, but also for traces of megastructures, vast artificial constructions that a civilization might build around its star, or for the telltale flashes of lasers used for interstellar communication. And the result of all these efforts, of this decades-long patient search with ever-improving ears and eyes? Nothing. Absolute, deafening silence. The sky remains mute. There are no artificial signals that stand out from the background noise. No traces of gigantic engineering projects obscuring the light of distant stars. And despite countless reports and stories, there is not a single scientifically confirmed proof of a visit to our planet. The great, silent void of the cosmos simply seems to ignore our question. Let us dwell on this thought for a moment. Hope slowly gives way to a feeling of unease. The initial excitement of the search has turned into a quiet disappointment, which is now transitioning into a deeper, more unsettling question. If the universe is so vast, full of stars and planets, why is it so quiet? This silence is not a peaceful, gentle tranquility. It is slowly starting to feel like an answer, but one whose meaning we do not yet understand. It hangs heavy in the cosmic air, leaving us with a growing premonition that sends a quiet chill down our spines. The search continues. But with each silent year that passes, the mystery does not get smaller, but only larger and more urgent. Chapter 3: The Firstborn Hypothesis. Having considered the dizzying emptiness and vast timescales of the universe that make the Fermi Paradox so tangible, let us now take a different, perhaps equally profound perspective. An idea that is both humbling and filled with a quiet hope. Imagine for a moment that the answer to the question, "Where is everybody?" is not that we are alone or have been overlooked, but something much simpler. We are the first. This idea, known as the Firstborn Hypothesis, suggests that life, especially complex, intelligent life, is a relative newcomer on the cosmic scale. Our universe, as unimaginably old as it may seem to us at 13.8 billion years, may have only just entered the era in which the conditions for civilizations like ours are truly ripe. Let us gently unfold this thought. The very first stars that lit up after the Big Bang consisted almost exclusively of hydrogen and helium, the lightest elements, the building blocks of life as we know it: carbon, oxygen, nitrogen, and the materials from which rocky planets like our Earth are formed. Silicon, iron, magnesium did not yet exist. These heavy elements had to be forged first in the hearts of stars and in the fiery explosions of supernovae. It took several generations of stars, living and dying, to slowly enrich the universe with the dust from which planets and eventually living beings could later form. This process took billions of years. Furthermore, not every place in our galaxy is equally hospitable. In the dense, turbulent centers of the Milky Way, cosmic radiation is intense, and supernova explosions are frequent. Stars and their planetary systems would be constantly sterilized there. In the outer fringes of the galaxy, on the other hand, the heavy elements are too sparse. There is a galactic habitable zone, a quiet, stable ring where the conditions are just right. Scientists believe that this ring has only developed and expanded outward over time. Perhaps our solar system is one of the first to have formed at the right time in the right place to allow for a long, undisturbed evolution. When we look at this cosmic timeline, our own arrival may no longer seem so late. The 4.5 billion-year-old Earth and the few thousand years of human civilization are then no longer an insignificant afterthought, but possibly the first quiet breath of consciousness in our corner of the cosmos. The silence we perceive in space would then not be the silence of a graveyard, but the silence of a nursery just before the first child awakens. This idea carries a deep responsibility. If we are the first, or among the first, then there are no wise elders in space from whom we can learn. There is no cosmic help to save us from our own mistakes. We are the pioneers who must first forge the path. Every decision we make, every mistake and every triumph, could be of unimaginable importance. The burden, but also the privilege, of being the first to carry the torch of consciousness through the darkness rests on our shoulders. It is a thought that calls for humility, and at the same time awakens a cautious optimism. We may not be at the end of a long story, but at the very beginning of a new cosmic chapter that is just beginning to be written. Chapter 4. They are here, but hidden. Imagine the night sky is not empty. Imagine the countless stars are not just distant suns, but also the eyes of an invisible gallery. A thought not meant to disturb but to fascinate. What if we are not alone, but simply, left undisturbed? Let's allow this thought for a moment gently and without fear. It is the idea known as the zoo hypothesis. In this scenario, Earth is a vast cosmic nature preserve. A civilization, or perhaps many, that is eons ahead of us technologically and perhaps philosophically, has discovered us. But instead of landing with fanfare, they chose silence. They observe us just as we study rare animals in a pristine jungle from a distance, so as not to disturb their natural behavior. Every step of ours, from the first controlled fire to the first step on the moon, is perhaps carefully watched, catalogued, but never influenced. They see our wars and our peace, our art and our folly, and they pause. They do not intervene. This principle of non-interference is reminiscent of an idea from our own stories, the Prime Directive from Star Trek. It is a moral code that prohibits interfering in the development of less advanced cultures. Imagine a civilization so wise that it regards this principle not just as fiction, but as a universal law. They might have realized that premature contact would have unforeseeable consequences. Our social structures, our religions, our entire sense of self could shatter if we were confronted with a truth for which we are not yet ready. So they wait, patiently, for millennia. They protect us from themselves by remaining hidden. Perhaps it is a kind of galactic quarantine, but not in the sense of a punishment, but rather like the loving isolation of a seedling that is still too delicate to be exposed to the full weather. From their perspective, we might appear technologically and emotionally primitive, a species still grappling with internal conflicts, bringing its own planet to the brink of imbalance. Contact could be considered irresponsible. Like handing a complex and dangerous tool to a child, they might be waiting for a sign that we have grown up. What could this sign be? Perhaps overcoming our divisions, creating a global community that lives sustainably with its environment. Only then, when we prove that we can live in peace with ourselves, would we be ready to meet the cosmos. An even deeper and stranger twist on this idea is the planetarium argument. What if the reality we perceive is itself a protective measure? Imagine that the universe is in truth a much more dangerous and stranger place than we can imagine. Perhaps it teems with phenomena our minds cannot comprehend, or with dangers our young civilization could not handle. In this scenario, benevolent observers might have created a kind of protective bubble around us, a perfectly simulated reality. The sky we see would then be the ceiling of a cosmic planetarium, showing us the stars in a safe, understandable form while shielding us from the overwhelming truth out there. Every star, every galaxy would be a projection, placed for our protection and our slow learning. It is not a thought meant to frighten, but one that evokes a sense of protected wonder. The idea that our existence could be so precious that a higher intelligence would go to the unimaginable trouble of preserving it, of letting us grow undisturbed, whether as an observed zoo, a culture in quarantine, or inhabitants of a protective planetarium. All these ideas paint a picture of a universe that is not empty and indifferent, but full of hidden depth and perhaps even care. And so we linger under the silent, vast, starry sky, wondering what invisible eyes are watching with us as we slowly drift into the mysteries of the night. The next step of our journey takes us to the physical traces that may have been left behind after all, to the echoes in stone and legend that might whisper of distant visitors. Chapter 5: The most terrifying answer. After contemplating the immeasurable vastness of the cosmos and the staggering number of possible worlds, a question remains, resonating like a soft, persistent echo in the silence of space. Where is everybody? This question, known as the Fermi Paradox, has troubled many thinkers, and one of the most profound and perhaps most terrifying answers to it is the theory of the Great Filter. Imagine this filter not as a physical sieve in space, but as a series of evolutionary and technological hurdles that life must overcome to evolve from a simple beginning to an interstellar civilization. Each hurdle is so immense that it is almost insurmountable. The fact that the universe seems so silent suggests that this filter exists and is extremely effective. It weeds out civilizations before they can ever reach the stars. The crucial question for us, however, is, does the Great Filter lie in our past or in our future? Let us pause for a moment and consider both possibilities. If the filter is behind us, it means that we have accomplished something extraordinary. We have passed one of the extremely improbable hurdles where almost all life in the cosmos fails. What could it have been? Perhaps it was the very first hurdle, abiogenesis, the origin of life from non-living matter. Imagine the early Earth, a chaotic volcanic planet surrounded by a dense alien atmosphere. In a warm little pond or in the boiling darkness of a hydrothermal vent on the ocean floor, complex molecules like amino acids had to randomly assemble into a self-replicating structure. The probability of this could be so astronomically low that it may have happened only once in the entire visible universe. Here, with us, in that case, life itself would be the Great Filter. Or perhaps the filter was the next step, the evolution of the eukaryotic cell. For almost 2 billion years, life on Earth consisted only of simple, nucleus-free bacteria and archaea. Then something miraculous happened. One cell swallowed another, but instead of digesting it, they formed a symbiosis. From this union emerged the complex cell with a nucleus and mitochondria, the small powerhouses that provide us with the energy for complex, multicellular life. This step was so unique and transformative that it might be the hurdle at which most life forms on other worlds fail. Possibly it was also the development of intelligence at our level. Evolution has produced countless brilliant solutions, but only a single lineage led to a species that makes tools, uses abstract language, and questions the laws of the universe. Intelligence as we know it may not be an inevitable development, but a rare evolutionary fluke, a risky experiment that usually ends in a dead end. If any of these steps was the filter, then we are the survivors. Then the silence of the universe is not an omen, but a testament to our incredible rarity. But what if the filter is not behind us, but ahead of us? This possibility is the true source of the existential dread that the Fermi Paradox triggers. If the emergence of life, complex cells, and intelligence is relatively common, then the filter must lie in the future. It would then be a hurdle that technological civilizations regularly reach, but almost never overcome. What form could this future filter take? The most obvious and tragic answer is self-destruction. A civilization could develop the technological capability for global annihilation through nuclear weapons, uncontrollable artificial intelligence, or custom-designed bioweapons, before it attains the social and ethical maturity to handle it responsibly. Perhaps this is the fate of most young civilizations. A brief, brilliant flash followed by eternal silence. Another possible filter could be ecological collapse. A civilization could be so successful in its growth that it overloads the planetary systems that sustain it. Irreversible climate change, the complete depletion of critical resources, or a collapse of the biosphere could destabilize a global society and throw it back into a pre-technological age from which there is no escape, because the easily accessible resources have already been consumed. The silence of the universe in this light is not peaceful, but eerie. It is like looking into a deep dark forest and hearing absolutely no sound, not even the chirp of a cricket. One would not think, how peaceful, but rather, something is very, very wrong here. Every civilization that looks up at the stars is looking into a mirror of its own possible future. The silence is a warning. It whispers that the path we are on is lined with the invisible ruins of countless others who did not make it. The most terrifying answer to the question, where is everybody, is therefore not that we are alone. It is the possibility that we are not alone, but merely the next in a long line of civilizations standing before an insurmountable wall. Whether this wall is already behind us or still awaits us is perhaps the most important question of our time. And unlike the silent civilizations before us, we may still have the chance to choose our own answer. We take a deep breath and let this heavy but important realization sink in for a moment before we continue our journey. Chapter 6. We are listening on the wrong frequency. After all the frightening possibilities of the great filter, let us now take a more hopeful perspective. What if the silence of the universe is not real silence at all? What if we are simply listening on the wrong frequency? Imagine for a moment the development of our own technology. Like a seed that first germinates slowly and then grows explosively. Just a few hundred years ago, the fastest message was one a horse could carry. A little over a century ago, we began to experiment with radio waves, these invisible currents that travel through the air. For us, this was a miracle, a magical way to send our voices across oceans. In our youthful enthusiasm, we assumed that any other intelligent civilization would also follow and master this path. So we built enormous dishes, pointed them at the sky, and listened on precisely these frequencies. It is as if we have just discovered drumming for ourselves, and now expect the entire universe to drum to the same rhythm. But what if, on a cosmic scale, radio signals are as primitive as smoke signals? Imagine an early human sitting on a hill, carefully placing damp leaves on a fire to send a cloud of smoke to the sky. He looks expectantly to the horizon. Miles away, another tribe might see this sign. But what if he is trying to communicate with a modern airplane in the sky? The pilots would barely notice the smoke cloud, let alone understand it as a complex message. They communicate via radio, via digital data streams. Perhaps it is the same with us and the stars. We send our smoke signals into the cosmos and listen for the echo. But an advanced civilization, thousands or even millions of years ahead of us, might have long since adopted much more subtle, elegant methods. Perhaps they communicate with neutrinos, these ghostly particles that rush through entire planets and stars almost without resistance. A message made of neutrinos would not be a loud shout, but a gentle breeze, a whisper that penetrates matter itself, and would be completely inaudible to our crude radio antennas. Or perhaps they use gravitational waves, those fine ripples in space-time itself that arise when massive objects like black holes dance and merge. The message riding on the waves of gravity would not be a wave in the ether, but a tremor in the universe itself, a rhythm that pulsates through the very foundations of reality. To hear that, we would not need ears, but a completely new sensory organ for the geometry of space. And then there is quantum entanglement, that strange phenomenon Einstein called spooky action at a distance. Two particles inextricably linked, no matter how far apart they are. If you change one, the other changes instantaneously, faster than light. A civilization that has mastered this would no longer need to send signals. Their communication would be a silent, instantaneous dialogue across the galaxies. The most beautiful and perhaps most reassuring analogy is that of the cosmic ocean. Imagine we are a species of intelligent fish living deep at the bottom of the sea. We have just learned to use sound waves in water to communicate over long distances. Now we listen into our ocean and wonder at the silence. Where are all the other fish, we ask ourselves. Meanwhile, above the water's surface, in a world of air and light completely alien to us, the entire network is filled with Wi-Fi signals, radio broadcasts, and satellite conversations. The air vibrates with information, but we fish in our watery world can perceive none of it. We are searching for wet signals in a dry world. This idea is not discouraging, but profoundly hopeful. The silence we hear may not be an empty silence, but a full one. The cosmos may not be an empty house, but a house full of conversations conducted in languages and by methods we cannot even dream of yet. Our search has only just begun, and the next step is not to shout louder, but to learn to listen better and to open our senses to the unexpected. Chapter 7. We are a cosmic stroke of luck. Let us now pause for a moment and lift our gaze up to the stars that sparkle in the silent night above us. Imagine a clear, cool night, far from the city lights. The air is pure, and the Milky Way stretches across the sky like a broad, luminous river. From here, the universe seems infinite and full of possibilities. And yet, a deeper, more fundamental question arises: why could life, why could consciousness arise here at all? The answer is perhaps the greatest story of all. It is a tale of a series of cosmic coincidences, so improbable and so perfectly aligned that they can give us a sense of deep humility and gratitude. Scientists call this idea the rare Earth hypothesis. It suggests that a planet like ours, where complex, intelligent life can emerge, may be an absolute rarity in the universe. Our journey begins far out in the solar system with a silent giant, Jupiter. This massive gas planet, more than 1,000 times the size of Earth, is our invisible guardian. With its enormous gravity, it acts like a cosmic vacuum cleaner or a celestial goalkeeper. It intercepts countless comets and asteroids that are on a collision course with the inner solar system from the depths of space. Without Jupiter, the Earth would be subjected to a constant bombardment that would have repeatedly set back the development of higher life or made it entirely impossible. Every peaceful day on Earth, every undisturbed flowering of a civilization, is also a silent thank you to this distant giant. But let's look closer to home, to our constant companion in the night sky, the moon. It is far more than just a romantic light or a timekeeper for the tides. Our moon is unusually large compared to its planet. This peculiarity has a decisive consequence. Its gravitational pull stabilizes the Earth's axis. Without the moon, our planet's axis would wobble wildly over long periods. The poles could wander to the equatorial region and back again. The result would be an extreme and chaotic climate where ice ages and heat waves come and go unpredictably. The stable seasons, which made agriculture and thus the sedentariness and culture of humanity possible, are a direct gift of this gentle, constant embrace of our moon. At the same time, deep beneath our feet, another force is working for us. Plate tectonics, the slow gliding of the continents, is the engine of a vital cycle. Through volcanoes, carbon dioxide is released from the Earth's interior into the atmosphere, which warms the Earth. Rock weathering binds this CO2 again and transports it back into the Earth's mantle. This gigantic process, lasting millions of years, acts like a global thermostat. It has kept the Earth's climate within a relatively narrow, life-friendly corridor for eons. Without this constant renewal of the Earth's crust, our planet might have become a frozen ice ball or a boiling hot Venusian trap. And even this dynamic interior gives us yet another protection. the magnetic field. Generated by the liquid iron core of our planet, it stretches like an invisible cocoon around the Earth. This field deflects the dangerous high-energy radiation from the sun, the solar wind, past us. Without this shield, the solar wind would slowly strip away our atmosphere and make life on the surface impossible. So we find ourselves on a Goldilocks planet, not too hot, not too cold. We orbit a stable star, at the perfect distance, in a quiet neighborhood of our galaxy, the so-called galactic habitable zone, far from exploding supernovae and the dangerous radiation of the galactic center. We have a big brother who protects us, an oversized moon that stabilizes us, an inner fire that regulates our climate, and an invisible shield that protects us from cosmic radiation. Each of these factors in itself may not be extremely rare. But the convergence of all these conditions at the right time in the right place is a cosmic stroke of luck of unimaginable proportions. We can look to the stars and see a chain of fortunate coincidences that gave us the privilege of being here at all, and thinking about them. Perhaps in this infinite expanse we are indeed very, very rare. This realization leads not to arrogance, but to a sense of connection and deep responsibility for this extraordinary blue jewel we call home. And in this silent gratitude we find a profound peace. Chapter 8: Advanced civilizations leave the material world. Imagine a civilization evolving over millennia, even millions of years. It masters the energy of its planet and becomes a Type 1 civilization on the so-called Kardashev scale. It learns to harness the entire energy of its star, perhaps through a vast Dyson sphere, and achieves the status of a Type 2 being. Finally, it expands and uses the energy of its entire galaxy, unimaginably powerful, a Type 3 civilization. But what comes after that? Is physical expansion, the conquest of stars and galaxies, really the ultimate goal? Let us pause for a moment and listen to another quieter possibility. What if the next step is not outward, but inward? A civilization that has mastered matter and energy to such a degree might reach a point where the constraints of the physical world become a burden. Bodies need to be nourished. Planets have finite resources, and even the stars will one day burn out. The universe is a place of entropy, of inexorable decay. But one thing is potentially infinite: information. Imagine these beings beginning to transfer their essence, their consciousness, into another form. Not of flesh and blood, but of pure code, of light and data. They create virtual worlds that far surpass material reality in their complexity and beauty. Why traverse the cold, empty expanses of space when you can create an entire universe in the blink of an eye? One that corresponds exactly to your own imagination. A world without pain, without age, without death. A post-biological existence. In these digital realms, the only limit is the imagination. They could relive the history of their civilization 1,000,000 times in perfect simulation, trying out every possible decision, exploring every alternate timeline. They could experiment with the fundamental laws of physics, create new forms of mathematics, or simply exist in a state of pure, unadulterated bliss in an ocean of consciousness. The coarse material world, with its slow speed of light limits and its unpredictable catastrophes, would seem as distant and insignificant to them as the bustle in a drop of water might seem to us. They have not disappeared or gone extinct in the classic sense. They have simply withdrawn. They have ascended. Their energy signatures would fade from the physical universe. Their vast stellar structures would slowly decay and turn to cosmic dust. To younger civilizations like ours, it would look as if they had vanished without a trace. But in reality, they have only changed the playing field. They have shed their material shell and become something else, pure information, eternal thought in a self-created paradise. They are no longer interested in our affairs, not out of arrogance, but because their plane of existence has become so fundamentally different. They have finished the finite game of matter to begin the infinite game of consciousness. And as their traces in the cosmos slowly fade, a whole new kind of eternity begins for them, the nature of which we can hardly imagine, as we are only just beginning our own journey through the stars. Chapter 9: The universe is a dangerous place, in the infinite silence of the cosmos, in this vast velvety darkness that we see above us every night. A question lies hidden. It is a quiet but persistent question that astronomers and dreamers have long been asking. If the universe is so unimaginably large, With billions of galaxies and trillions of stars, why have we never heard a sign of other intelligent life? This silence is known as the Fermi Paradox, and there are many possible answers to it. Some hopeful, some neutral, and one that sends a shiver down our spines. Let us for a moment explore one of these darker ideas, a thought experiment formulated by science fiction author Lou Sixon in his story, The Dark Forest. Imagine the universe not as an empty space, but as a vast pitch-black forest in the dead of night. In this forest, countless hunters are hiding. Each hunter is a civilization, moving silently and with bated breath through the undergrowth. They all listen, but no one dares to make a sound, because in this forest there is an iron rule. The first creature to reveal its presence becomes the target for all others. This unsettling theory is based on a few simple but relentless assumptions. The first and most important assumption is that the ultimate goal of any civilization is its own survival. It is a fundamental drive inherent in all living things, a universal imperative. The second assumption is that civilizations constantly want to grow and expand, but the resources in the universe, however vast they may be, are finite. Like waves emanating from a stone thrown into water, cultures spread until they inevitably encounter others. Here comes the third and crucial assumption: the immense distance and the associated time delay in communication. Imagine you discover another civilization 50 light-years away. You receive a signal, a message of peace. But this signal is 50 years old, in the time it takes for your reply to get there, and for another reply to come back to you. 100 years have passed. In a century, a civilization can develop technologically in ways we can't even imagine. Can you be sure that their peaceful intentions still hold? Can you trust that they have not grown into a threat in the meantime? This uncertainty, this lack of trust across light years, is called the chain of suspicion. You can never know the true intentions or the true technological strength of another civilization in real time. Even if another culture is benevolent, it cannot be sure that you are. From this mutual fear arises a terrible but logical consequence. If survival is the ultimate goal and you cannot trust another potentially exponentially growing civilization, what is the safest course of action? The dark forest theory suggests that the only absolutely safe strategy is a preemptive strike. The civilization that is discovered first is the one that is annihilated before it can become a threat itself. It is not an act of hatred, but a cold, rational decision born of the survival instinct. Under this premise, the cosmic silence suddenly becomes understandable. The universe is not silent because no one is there, but because everyone is hiding. Every civilization is listening intently into the darkness, but none dares to send a signal of its own. Silence means survival. To send a sign of life, as humanity is doing with projects like METI, messaging to extraterrestrial intelligence, would be like shouting your name and location loudly in this dark forest. Let this thought sink in for a moment, but do not let it alarm you. It is only a theory, one of many, a captivating piece of fiction that makes us think about our place in the cosmos. The silence of the universe can also mean that we are simply the first, the pioneers in a still empty forest, or that the distances are simply too vast to be bridged. We do not know the truth, and in this not knowing there is also a kind of peace. There are still so many other, more hopeful possibilities that we can explore in the coming moments. Chapter 10: Microbes Everywhere, Civilizations Nowhere. Let's detach ourselves for a moment from the familiar constellations in the night sky and expand our perspective once more. The question of whether we are alone has accompanied us on our journey, but perhaps we have been asking it the wrong way. What if the universe is not silent and empty, but filled to the brim with life, just not the kind of life we are looking for? Imagine countless planets orbiting distant suns, their surfaces covered by oceans, their atmospheres filled with gases that indicate biological processes. A cosmos that hums and teems with activity. But when we zoom in closer, we find no cities of light, no radio signals calling through the void. Instead, we find worlds inhabited by microbes. Oceans colored green or red by countless billions of tiny algae. Soils threaded with the invisible networks of bacteria and fungi, patiently turning rock into nutrients. Perhaps this is the norm in the universe. Life may arise easily wherever conditions permit, but it remains in its simplest form. The history of our own planet tells a similar story. For almost 3.5 billion years, Earth was the sole domain of bacteria and archaea. Simple single-celled organisms that drifted in the oceans, formed the first coral reefs from biomass, and slowly, over unimaginable eons, enriched the atmosphere with oxygen. They were the silent architects of our world, but they did not look to the stars. Later, more complex life forms emerged. Think of the dinosaurs, the majestic rulers of the Cretaceous period. They populated the Earth for 165 million years, a time span so vast that our entire human history is barely a blink of an eye within it. They developed a breathtaking diversity of forms and sizes, adapting to every conceivable niche. And yet, in all those millions of years, not a single dinosaur sharpened a tool, lit a fire, or invented a wheel. This teaches us a humble lesson about evolution. Intelligence, as we define it, the ability for abstraction, for technology, for self-reflection, is not an inevitable goal of life. Evolution is not an arrow that inexorably points toward complexity and consciousness. It is a process of adaptation that finds countless ways to ensure survival. A sharp tooth, a thick skin, or the ability to photosynthesize are often far more effective solutions than a questioning brain. This could be what the universe is like. Billions of planets where life exists in a simple, stable equilibrium. Worlds with endless silent forests of fungus-like growths. Seas where simple, animal-like creatures float through the eternal twilight without ever forming a thought. Life is everywhere, but civilizations may be found nowhere, except here. This idea carries a gentle melancholy. The silence of the cosmos would not be the silence of emptiness, but the silence of a garden where no one names the flowers. Yet, in this melancholy, there is also a spark of something special. It means that we, in this tiny moment on this small planet, may be the only ones who can look up and ask the question, is anyone out there? We are not just part of the universe. We are the part through which the universe contemplates itself. And as we prepare to look even deeper into the mysteries of time, this realization carries us forward with a sense of stillness and wonder. Chapter 11. Civilizations exist too briefly. Imagine for a moment the infinite expanse of the cosmos, a silent, dark sea of space and time, stretching across unimaginable distances. In this ocean of eternity, our own existence, the existence of our entire human civilization, is little more than a fleeting moment. Let us pause on this thought for a moment and feel its true meaning. We humans often view our history as long and eventful. The pyramids of Giza, the Acropolis in Athens, the great cities of the Maya and Aztecs, they all seem to be witnesses of a deep past, yet on a cosmic scale, the entire duration of what we call civilization is barely more than the blink of an eye. Perhaps 10,000 years of organized society, agriculture, city building and writing. 10,000 years, an impressive number for a human life, but vanishingly small in the face of the age of the universe. The universe itself is about 13.8 billion years old, a number so vast that our minds can hardly grasp it. 13,800 million years. If we were to consider this immense span of time as a single long year, then the entire recorded history of humanity would be only the last few seconds before midnight on December 31st. Our civilization is a tiny flicker in the cosmic night. Imagine a summer meadow at dusk, filled with the gentle dance of fireflies. Each one lights up for a brief, magical moment, a tiny spark in the darkness before extinguishing again. Civilizations in the universe could be just that, countless little lights flashing on and off at different places and at different times. They exist for their own short span, perhaps a few thousand, perhaps 10,000 years, and then disappear back into the great silence. The probability of two of these fireflies lighting up at exactly the same time and close enough to perceive each other's light is vanishingly small. A civilization might have flourished on a distant planet for eons, long before the first life arose on Earth. Another might arise in the distant future, long after our sun has burned out. We are like ships sailing in the infinite night of the cosmic ocean, each on its own course, on its own journey through time. Rarely, infinitely rarely, do the paths of two such ships cross. They might just miss each other in the dark, perhaps catching only a flash of the other's light on the distant horizon, without ever knowing what it was. A signal that has traveled for millions of years might reach a world that is not yet ready to receive it, or one whose inhabitants have long since vanished. This realization is not sad, but fills us with a deep, peaceful humility. It shows us how precious and unique our own little moment in the light is. Our brief flicker here on this planet, amidst the infinite darkness, is a rare and wonderful event. Countless cultures in human history were such lights. They shone brightly, created impressive worlds, and left echoes before they returned to the silence of time. And so we travel on, carried by the silent currents of time, and look with reverence upon the transience of all being. Chapter 12. The modern search continues. After all the big questions, the countless hypotheses, and the quiet moments of uncertainty, we now return, back to the here and now. For the great silence has not discouraged us. On the contrary, it has made us more inventive, more patient, and more hopeful. The search continues, and it is more powerful today than ever before. Imagine, high above us in the cold, clear blackness of space, floats a marvel of technology. The James Webb Space Telescope. Its golden mirror, so huge and precise, is not just an eye into the universe's past. It is also our nose, sniffing the atmospheres of distant worlds. When the light of a distant star travels through the air of an exoplanet, it reveals its secrets. Webb can analyze these tiny changes in light and search for traces we call biomarkers. It looks for the familiar hint of oxygen, which could indicate photosynthesis. It searches for methane, which here on Earth is often produced by living organisms. If it finds both together, it would be a strong indication, not proof but a whisper of life across light years. But we are not just looking for traces that resemble life as we know it. We are also looking for signs of intelligence, for the fingerprints of technology. Imagine a distant world whose atmosphere contains traces of gases that hardly occur in nature. Perhaps industrial pollutants, an unintentional testament to a civilization. We call these technosignatures. We might even be able to detect the gentle glow of cities on the night side of a planet, an artificial gleam in the dark. And then there are the really big ideas. The search for Dyson spheres, those hypothetical megastructures that would envelop an entire sun to harvest all its energy. Such a discovery would be unmistakable. It would be proof of a civilization whose capabilities exceed our wildest dreams. While Webb scans the sky, here on Earth we are listening more closely than ever before. The Breakthrough Listen project is pointing giant radio telescopes at 1 million of the closest stars to us. It is the most comprehensive search for extraterrestrial intelligence ever launched. In the mountains of China stands fast, the world's largest single-dish radio telescope, a gigantic bowl set into the landscape. It listens with incredible sensitivity for the faintest signals from the depths of the cosmos. Any day, any hour could bring the signal that changes everything. And something else has changed. Our own attitude. The study of unidentified anomalous phenomena, formerly known as UAPs or UFOs, is slowly being brought out of the corner of pseudoscience. Scientists and governments are beginning to realize that any unexplained phenomenon in the sky deserves a serious, data-driven investigation. We are becoming more open, more methodical, and less biased. We are learning that admitting we don't know something is the first step toward true discovery. We are getting better at searching. Our tools are becoming sharper, our methods smarter, and our eyes and ears ever more vigilant. The silence is still there, yes, but it feels different. It is no longer the empty silence of an abandoned room. It is more like the tense quiet before the start of a concert. We don't know what to expect, but we are ready to listen. Outro. The beauty of the question of where are they, has sent us on a journey, not just into space, but also to ourselves. And now, at the end of our journey through the hypotheses and possibilities, a final profound question arises. What does this search mean for us? What does the silence, or a possible answer, say about our own place among the stars? The Fermi Paradox has no definitive answer. Not yet. Perhaps we will find it tomorrow, perhaps in 100 years, perhaps never. But the question itself, this deep, persistent question, is precious. It forces us to think beyond ourselves, beyond our small blue planet, and to see ourselves in the larger context of the cosmos. Think for a moment about the three possible truths that lie before us. If we are alone, the only conscious beings in this unimaginable vastness, then we are infinitely rare and precious. Every thought we think, every work of art we create, every act of love and compassion is a unique gift to the universe. We are the eyes through which the cosmos contemplates itself. The responsibility is immense, but so is the privilege. If we are not alone, if others are waiting for us out there, then the greatest adventure in human history awaits us. The first encounter with another intelligence would change everything. Our philosophy, our science, our very understanding of life would expand into dimensions we cannot even imagine today. It would be a moment of cosmic community, an end to a loneliness we may not have noticed until it was over. And if we simply do not know, if the mystery remains, then that too is beautiful. For the unknown invites us to dream, to search, to hope. It keeps us humble and curious. The stars remain a mystery, an infinite book with blank pages on which we can write our questions. The next time you look at the sky on a clear night, it will no longer be the same. The silence between the stars is not empty. It is filled with possibilities. Each point of light could harbor a world, tell a story, ask a question. And the silence itself, it doesn't mean anything yet. It is not an end but a beginning. A breath taken before the first word of a conversation that may be just beginning. Good night, sleep well under the stars, and dream of the countless possibilities that await us in the silent darkness.